students, in this particular module, we are going to study the explanation of results of dihybrid cross. Here, let's first have a look at the phenotypic ratio. So students, we already know that Mendel started his experiments with pure lines. That is, he chose plants producing yellow round seeds as well as green wrinkled. Further, we saw that the genotype for both was homozygous. That is, they were homozygous dominant for yellow round and homozygous recessive for green wrinkled. These seeds further gave rise to gametes, but the gametes that were produced were seen to be only one type. That is, the yellow round gave rise to alleles which were all dominant, and the green wrinkled gave rise to gametes which were all recessive. Further, all these gametes fused to give rise to the F1 generation. Students, the F1 generation that we see is all yellow round, but with a genotype of heterozygous. So, F1 generation that is giving rise to the genotype that is heterozygous but still appears to be yellow round is, as we know, thanks to the law of dominance. So students, further, this F1 generation will give rise to alleles. Let's see how. So the alleles that you see that are produced here are independent of each other. When I say that, it means that each gamete receives only one allele from each pair. That is, when they segregate independent of each other. Let's see how. For example, if I am having a gamete which is produced with the allele that is dominant for its seed color, can have an equal possibility of receiving both dominant as well as recessive trait for its seed shape. Hence, I am having two combinations of gametes that are formed here. Similarly, students, if I am having gametes which is receiving a recessive trait for its seed color, has the equal possibility to receive both dominant as well as recessive trait for its seed shape, thus producing total 4 types of gametes, but each in the ratio 25%. So students, we saw how exactly our gametes got segregated independent of each other. This is followed by the selfing of our F1 generation. Now students, we have already seen that the 4 types of male gametes that fuse with the 4 type of female gametes produce total 16 combinations, which can very well be studied with the help of our Punnett square. Students, here in this Punnett square, we are strictly going to pay attention to the phenotypic ratio. So let's see, the first that are forming are all yellow round seeds. There are total 9 yellow round seeds that are produced, followed by the 3 yellow wrinkled seeds, which are further followed by 3 green round seeds and the remaining one that is green wrinkled. Again, I mentioned students, here we are concentrating only on the phenotypic ratio. So therefore students, the phenotypic ratio that is formed is 9:3:3:1, where 9 seeds were seen to be yellow round, 3 were seen to be yellow wrinkled, 3 again seen to be green round, and 1 which was seen to be green wrinkled. But student, the question that arises is, what about our genotypic ratio? Will the genotypic ratio be the same? Let's see in our next module. So students, in this particular module, we are done with the phenotypic ratio. Next module, we will start with the genotypic ratio for the dihybrid cross. Thank you.